Okay, so we got this linear dE because all versions of y are linear functions of y. They're just y to the first power, no cosines of y, no logs of y, no y squareds. Remember that right there means fourth derivative, not y to the fourth. So it's linear. It's homogeneous because the right side equals 0. Constant coefficients because all my coefficients in front of y's are constants. Hey, we know how to solve these. We assume a solution. Y equals e raised to the lambda. Let's assume our variable is x here. And I'm not going to write out y prime, y double prime, and so forth. We know, or you should know, what you're going to get for each of these. You know that we're going to get lambda to the fourth minus 4 lambda cubed plus 16 lambda plus 32 times e to the y x, or lambda x, equals 0. And verify that for yourself. The order of the derivative is the power on your lambda. Remember, that's 0 order derivative, so no lambda there. Because that's first derivative, that's lambda to the first. This is the one people mess up. They want to put a lambda here by this y. Okay, this factor here is never equal to 0, so we can divide it through, and we get our characteristic polynomial. Now we got to solve this. This were quadratic, we just use quadratic formula if we couldn't factor it and we'd be done. This is not. So we're going to have to use the rational root theorem to find some roots. So rational root theorem says your roots, possible roots, it's possible none of these will work, but possible rational roots are factors of your constant. So I'm going to list out here all possible factors of 32. So that's 1, 2, 4, 8, 16, and 32 over all possible factors of your leading coefficient, which in this case is just 1. Now we're supposed to try these one at a time until we find one that works, and then we factor it out. So we could try, if we say f of lambda is this polynomial, we could just start plugging these in. Some of them we can do in our head, like 1 is obviously not going to work. Or you can just look at it. 1, 4, 16, there's no way that's going to cancel out of 32. It's not big enough. But I'm guessing one of the 2's is going to work. So maybe we could try f of 2. So 2 to the 4th minus 4 times 2 cubed. And we could just do that for each of these. Plus 2, negative 2, plus all of them. And if that equals 0, we know we found a root. Or another way to do it is using synthetic division. So I don't feel like going through all this math here. I think 2 actually works. I know either 2 or negative 2 works. I'm going to do it using synthetic division. So I'm going to put my 2 here, the thing I think is a root. I'm going to write my polynomial here, but we can't have any missing powers. I need to write this as lambda to the 4th minus 4 lambda cubed plus 0 lambda squared plus 16 lambda plus 32. So my coefficients will be 1, negative 4, 0. 1632. And we bring the first guy down, and then it's multiply and add. Multiply 2 times 1 is 2, add straight down. Multiply, add straight down. Multiply, add straight down. Positive 8. Multiply, add straight down. This right here will be your remainder. If we were to divide by the factor x minus or lambda minus 2. That ain't 0, so 2 is not a root. Let's try negative 2, because I know one of them works. I looked up the answer. Bring the first guy down, and then multiply and add. Negative 2, negative 6. Multiply, positive 12, add 12. Multiply, negative 24. Add. Why is that not working? Okay, it wasn't working. I couldn't figure it out. I was like, I know the answers. I was being silly. That's second, not third. This was wrong. This would be lambda to the 4th plus 0 lambda cubed. There's no third derivative. Minus 4 lambda squared plus 16 lambda plus 32 equals 0. That's my characteristic polynomial. I had the 0 in the wrong place. 2 still doesn't work, but we could check it if we wanted to. So this should be 1, 0, negative 4 is 16, 32. And here we'll check 2 again, just to be sure. Bring down the first one, multiply, add straight down, multiply, add down, multiply, add, multiply, add. That's my remainder. It's not 0, 2 is not a root. We check negative 2. We could do all this with long division instead of synthetic division. Synthetic's just quicker. I used to hate synthetic division, but now as I'm getting older, I like it. So bring the first one down, multiply, add. Multiply, add. Multiply, add, multiply, add. We get 0. If you get a remainder of 0, that means this number out here is a root. So we want to factor that root out, but we've already done it. The synthetic division tells you what you would get if you factor out. We have now factored out the factor lambda minus negative 2 or lambda plus 2. And what we're left with, we got to now work backwards and figure out what everybody's powers will be. Because we started with a 4th degree polynomial, this will be 3rd degree. So that's lambda cubed, lambda squared, lambda, and then this will be the constant. So now we're working with lambda cubed plus 2 lambda squared plus 0 lambda plus 16 equals 0. And we rinse and repeat. And we could check, you could check yourself. Lambda equals negative 2 is another root here. Let's pull it out from synthetic division. So this will also prove it's a root. And see what we get left when we factor that out. So bring the first one down, multiply, add straight down, multiply, add straight down. Wait, something's not right. Oh, that's a negative. Sorry, right there. That's negative. It was right there in front of me. So then this would be -4, multiply will be 8, add down 8, multiply -16, add straight down, remainder 0. So -2 is still a root. So that means it's a double root. It appears twice. Okay, now what's left over? Remember, we're decreasing the degree of the polynomial every time. That was a cubic, this will be a quadratic. So what we got now is lambda squared minus 4 lambda plus 8 equals 0. And this won't factor anymore. This is going to give us complex solutions. So we could use quadratic formula to get the last two. We could do completing the square. That's how I'm going to do it because it's quicker. So I'm going to move that 8 to the other side, take half of this guy, which is 2 squared, and add that to both sides. Now the left side is a perfect square trinomial that factors lambda minus 2 squared. On the other side, we get, what is that, -4. Take square root of both sides. Don't forget our plus or minus. So lambda minus 2 is plus or minus 2i. So lambda is 2 plus or minus 2i. So then my 4 roots are -2, -2 because it was repeated, 2 plus 2i, 2 minus 2i. Now I can write my solution. Once you get all your roots, you've got your solution. So we'll get y equals C1 e to the -2x. Now, because we have a repeated solution, this guy here is going to pick up an extra x. The second one is going to be C2x e to the -2x. Anytime you have a repeated solution from your characteristic polynomial, each repeat picks up an extra value of x. If -2 appeared a third time, we get an x squared. It's an extra factor of x. Now, complex solutions. These guys here, this is a plus or minus bi. Those solutions look like e to the ax cosine of bx and e to the ax sine of bx. So you don't have to worry about the plus or minus. They'll always come as complex conjugate pairs. You'll always get a plus or a minus. So the plus or minus doesn't matter. What matters is the a and b, both of which are 2. So my next two solutions will be C3 e to the 2x cos of 2x and C4 e to the 2x sine of 2x. And there is the general solution. Now you have one of these problems coming up on a group assignment. It's called higher order, blah, blah, blah. It's got like a big long name. This is the kind of work I want to see. I want to see either long division, synthetic division, some kind of division, pulling out the roots, actually write out the list of all the possible rational roots, go through all this math to get your final solution. Okay, let's do a couple more undetermined coefficients. These are the problems. See, a lot of people won't watch the video this far, but I'm gonna give you a big hint here. These are the ones that catch you on. The people that are using Chegg, here's where I'm gonna get you. Because Chegg does these problems a completely different way, a way that does not appear in your book or in the Canvas course anywhere. These are the ones that are going to get you. All right, let's say we want to solve y double prime, say 10 and 2 minus 14y prime plus 24y. I think that works, right? So 12 and 2, yeah, equals, and we'll do, I don't know, maybe e to the 3x plus 2x minus 1. Okay, first we solve the homogeneous version. That's a y. So same work we just did. Assume y is equal to e to the lambda. I'm using x as the variable there, so I know to use x. And it's okay. I don't have to see you write down y prime equals lambda e to the lambda x, y double prime. It's okay to write this, and maybe it's a good idea to write these out. But you notice I didn't do it on the last one. I don't know why it just erased those there. It's okay to just jump straight to the characteristic polynomial. The order of the derivative is the power you get on lambda. So this will be lambda squared minus 14 lambda to the first plus 24 lambda. Zero derivatives there. And then I wrote a lambda. Zero derivatives there, so no lambda here. Times e to the lambda x equals 0. This guy is never 0, so we can get rid of him, and we get our characteristic polynomial. And this factors, because I just made it up so that it would factor. That's lambda minus 2, lambda minus 12. So we get two solutions, 2 and 12. And we know that our complementary solution what I like to call it YC will be C1 e to the 2x plus C2 e to the 12x. Excuse me. So we're 1/3 of the way done. Now we got to deal with this guy here, finding our particular solutions using the only allowed method. The only method you've been taught in this class is undetermined coefficients. Now, you can do undetermined coefficients one little piece at a time. So I'm just going to deal with just this guy first. We don't have to. We could do it all at once. And I've tried it, and it just gets really ugly. It's easier to do it one at a time. So let's call it YP1 for e to the 3x. That guy right there. So we assume that YP1 has the same form. He's somebody who, when I take either the original, the first, or the second derivative, I could get something that looks like this. And so that would just be some a times e to the 3x. Now here I do have to actually take the two derivatives. His first derivative would be 3a e to the 3x. His second derivative, taking the derivative here, 9a e to the 3x. Now I have to plug all three of these in to the original dE, being careful with the coefficients. So I'm plugging in here. So that I'll rewrite that. That was y double prime minus 14y prime plus 24y equals, and I just want that equal to e to the 3x. What was there? And I could put a number in there. I could change the problem here and make this a 7. That may make it a little more interesting, because most of the time you're going to have a number there. So let's throw a 7 there. And let's plug all these in. Y double prime minus 14 times y prime, and he was 3a e to the 3x, plus 24 times the original a e to the 3x is supposed to equal 7 e to the 3x. So literally just adding like terms here, I'm going to get 9, 14 times 3. Let's see, it'd be 28, 38, 42. So minus 42 plus 24 times a e to the 3x should equal 7 e to the 3x. And you guys check my arithmetic here. I'm doing all this in my head. So if I mess up the arithmetic, don't get mad at me. Let's see, that would be 33 minus 42. I think that's -9. Again, the point of this problem is to show you the process. So definitely forgive me if my arithmetic is wrong. So then A, I think, would be -7/9. So YP1 will be -7/9 e to the 3x. Okay, then we got this other guy. 2x minus 1. So that's a linear function. We want to assume then, we're making the assumption this might not work, but we're going to try and see if YP2 maybe is just some AX plus B. Now, I know when I took this class, this would drive me nuts. This used to bother me. I've already used up A, right? Like A is already on my page. Is it really okay to use the letter A again? Yeah, because I already finished that process. Like I've already solved for that A. I've moved on with my life. As long as I'm careful and I don't go back and like reread this down here somewhere, it's okay to reuse the same letter again. You don't have to, like some of these get so bad, like you'll get into Greek letters eventually. That we don't need to do that. Reuse A again, it's okay. Then YP2 prime would just be A, and YP2 double prime would be 0. So we plug all of those in to our DE. It's a Y. And that was 2x minus 1. Let me make sure I wrote all that correctly. Yeah, I got that part, and 2x minus 1. Okay, so nothing here. We're going to get a minus 14a plus 24 times the original ax plus b should be 2x minus 1. Okay, so now we just match up coefficients. So I'm going to rewrite this as 24ax plus b minus 14a. So this is my x coefficient that has to match this x coefficient. 24a must be 2. This is my constant that must match this constant. B minus 14a must be -1. Now, when you get here, perfectly fine if you want to throw this in your calculator, make a matrix out of it, because we're going to get some kind of system of equations. But most of the time, these are pretty easy to solve just by substitution. So we're going to get A equals 1/12 So then B minus 14 over 12 equals -1. B is going to be -12/12 plus 14/12. I think that's 2/12 or 1/6. So YP2 will be 1/12 X plus 1/6. Now we can put that all together. My general solution will be the complementary function plus those two particular solutions. The particular solutions don't pick up any constants of integration. All the C's are buried in here. So that was C1, 2 and 12. Plus, I don't remember what we got. We're going to check this solution, by the way. -7/9 e to the 3x plus 1/12 x plus 1/6. And that's what I got for my general solution. Let's check it just for fun. And if I did make any numerical errors in there, maybe I'll make an extra credit question for you guys to go and find my error. I did bring that 7 down, right? Yeah. Yeah, that's why I got a 7/9. All right. Let's take this guy and throw it into Wolfram Alpha and check it. So that was y double prime minus 14 y prime plus 24y equals 7 e to the, I need parentheses here, 3x plus 2x minus 1. Think that's what I wrote. I'll let it render it so we can see it. Looks right. Got the 7/9 was right. The 1/12 was right. I think I got B wrong on that last part. So this is on a test. This is the kind of stuff I want you to do. You go through all your work, you check your answer and you go, okay, well, I clearly screwed something up. Let me go back and figure out what I did wrong. There was something wrong in here. So A was 1/12. That was right. See right there. That B should have been 1 over 144. Oh, it was right here. That should have been 24B. I didn't distribute. So I got the 24A times X. I didn't hit the B with the 24. So this should have been 24, 24, 24. And then you'll get B equals 1 over 144. So I'm just going to fix this because I'm going to post this document. Maybe. It's kind of ugly. So that's the kind of stuff I want you to do on test. Go through all your work, check your answer. If you found out you made a mistake, go and find your mistake and fix it. So honestly, there's no reason to not get 100 if you actually know the procedures. Okay, I think that's a good place to stop for today.